Something has been simmering behind the scenes for a while, and now it's all ready, and Fluke have made their announcement that they're withdrawing their SM100, 200 and 300 plug-in socket testers, and there's nothing wrong with them. They're not faulty in any way, but they're recalling it because, as with all these socket testers, when you plug them in, if the earth is floating, then because these testers actually pass a small current to that, and because humans are super sensitive to current, it can give you an electric shock. And it's not a fatal electric shock, but it would give you a big surprise. I've tested the current in these, and it is quite surprising. However, I've got mixed thoughts about this. I'm thinking, it's just it's a known thing that these testers do pass that current in that way. But I'm guessing that Fluke are just wanting to protect themselves from litigation from, the people that, well, if you're on a site and you gave a plumber an electric shock via one of these, then they'd probably swear at you and laugh it off. If you did it in an office and an office worker got a tingle, they'd get all hysterical and they'd want compensation. It's just, unfortunately, it's what's happened with litigation culture these days. So let's see what Fluke have to say about it. And then we'll do some tests and see what current's involved. So February 2018, this is just out. Fluke Corporation has identified a safety issue concerning the Fluke SM100, 200 and 300 electrical socket testers. As a precautionary measure, Fluke has decided to voluntarily recall, it's purely voluntarily, all of these products and provide affected customers with free replacement products. More about that later. One of them is good, one of them is a wolf in sheep's clothing. We are sorry for the inconvenience this might cause you, but we hope that you'll understand customer safety is our utmost priority. So they're pulling these testers and some kits that include the tester. And then they go on to say the primary function of it is to detect the presence of an open ground in sockets or the polarity reversal. But sometimes the sockets are installed in metal boxes. Now, this is in the UK, it's a typical metal box. It's a metal back box with a metal plate in the front. It's used in industrial environments where you're going to ram forklift trucks into it. Well, maybe not. I don't think it would survive a forklift truck ramming, but it's designed for where things are going to get whacked about, and it's just more rugged than the plastic ones. And sometimes, and this is probably one of the worst scenarios, sometimes people use these as extensions, rugged extensions. They'll knock out one of the knockouts here, and they'll put in a cable gland, and they'll put a flex into it. And it means that if you were standing in a puddle and you picked one of these sockets up and then you plugged your tester into it, that would give you quite a surprise because you'd basically be holding the earth metal box. So that's what they're sort of hinting at here. They've played it down a little bit by pointing at the earth screw here, which isn't so much of an issue. But anyway, if it detects the missing earth condition, it will actually put a little bit of current to that. It's just part of the test, as I say. And they do point out it's giving an electric shock, but it's not life-threatening. Now, I have to say, anything above about, well, if you touch an electrical connection with one finger, 1 milliamp will give you a shock. If you were to grab it with your hand, you wouldn't feel that 1 milliamp. Roundabout, I would say, in my case, for my size, because I've tested this, 4 milliamps, I can actually start feeling it going sort of into the sort of wrist area. And upwards from that, it increases quite rapidly. And I found that 6 milliamps was quite extreme, but it's considered that about 10 milliamps is the point that you're actually going to have involuntary muscle contraction, and that is possibly a bit of an issue here. So, one of the things they say is, even a small shock is enough to give someone a surprise they could fall off a ladder. Okay. So, to date, Fluke is aware of only one instance out of more than 81,000 units sold where a user has experienced electric shock through the fault condition and no injury was sustained, but they've obviously reported it. And I guess maybe other people had tingles, but, well, I don't know. So, they are offering a replacement. If you return these, they will swap it for something else. They're giving you an option of two things. One, I've not got the latest version, but one of them is a set of Fluke test lamps. I say go for the test lamps. Actually, I say make your own mind up if you want to keep using these. It's up to you, but I'm not sure how intense Fluke is about wanting them back, destroying all the evidence as such. As I say, it's not what I'd regard as life-threatening, but if you're using it in an environment that you have complete knowledge of, control of, then it's fine. There is the risk that if you use this in a building and there is a break in the earth circuit somewhere, then someone holding a metal appliance could get a tingle off it. That is the downside. So if you do want to return it, you get the choice of a set of test lamps. And they do say it's a Fluke T90, and that's the upmarket version from this. These are all scuffed. These have been heavily used. These, I say, if you're going to get a set of electrical test lamps, I do actually recommend getting Fluke, because 2 reasons. They're quite well built. This is showing signs of cracking plastic. That's because they have been seriously abused in a heavy tool bag. It's what happens. But also, if you ever have an incident, then the health and safety will literally say, oh, what equipment was he using? And if it's not Fluke, it will make things more serious. And if it's Fluke, they'll go, oh, well, it was Fluke. That's fine then, because it's proper gear. And the Fluke does have all that extra protection. If you do poke it in somewhere you shouldn't be poking it, it'll have that. I don't think you could actually damage these ones. But the one they're offering is the T90. That's a good choice. The other thing they're offering is a C25 soft case for multimeters. That's one of those free cases that you get with most other cheap multimeters that Fluke charge more for. Another thing as part of that package deal is a Fluke socket tester. This isn't a Fluke socket tester, but it looks like it does pretty much the same stuff, and you can get it off eBay for 99 cents, including shipping. So given the choice of a junky set of posh test lamps, yeah, this is a winner, or a generic case and a cheap non-contact tester, go for the test lamps. That's my advice. But anyway, let's get this out of the way. The information, if you want it, will be on Fluke's website, I'm sure. I could have looked that up. Maybe I'll put a link to it down below. I'm guessing I don't know if it applies to other countries. I'm guessing it might just be a UK thing because of our uniquely, I say uniquely, we have earth sockets. Yeah, that's the main thing. So in a recent video, I was looking at different versions of these, and I said my favourite was this. Now, here's a note. If you do return your posh Fluke one, I'd recommend that you get one of these dinky ones, because of all the ones I tested, this one had the nicest circuitry. It doesn't normally come off that easily. I've had this. I used force to get this off. Here's an interesting thing, incidentally. The Fluke has 2 100 ohm resistors, one on the earth connection and one on the neutral connection, but none in the live connection. I thought they were fuses, and I'm not sure why they have those little resistors. They look like fusible resistors for some reason. And then it's almost like this company copied and said, oh, we'd better put a 100 ohm resistor between earth and the circuit and neutral. I don't know why they do that. All I can think is that if you protect 2 of the connections, it's going to prevent against any catastrophic failure if you're using them as fuses. I'm not sure. But the nice thing about this particular version of the tester is it uses very low current. And it also uses this fantastic big long lines of resistors. Everything's well spaced out. Of all the testers I looked at, this was the best. And this one was by far the shittiest. If you have one of these, consider dropping it in the bin. It's crap. It's not very good inside. It just, get yourself something decent. Sure, it's got the RCD or GFI test button on it, but that's just a frivolous whim. If you want to test the RCD or the GFI, go to the unit and press the button on it, and that will do the full proper test. Anyway, moving on. The circuitry in the Fluke is different than this one, because although it has the same functionality for the basic circuitry, it has extra circuitry. And I'm going to bring the notepad in here. It has some beefy resistors in the back. It's got 3 orange, which is 3.3 and 3.0, so it's 33k. And then it's got this little resistor in here, which is yellow, violet, orange, which is 47k. The big resistors here, the 33k resistors, are for the LEDs. Oh, let me draw this out. This is the easiest way to do it. In fact, shall I just zoom down under here? Let's make sure that's actually focused in. I think that is focused in. If it's not focused in, I'll just apologise later. But in these typical sockets, you have the neutral pin, the live pin, and the earth pin. And the classic tester in the old days was between any of those 2 pins, you'd have just had a resistor and a neon. But when they upgraded to using LEDs, because I guess LEDs are trendy, what they actually did was they put a resistor in and an LED diode in series to protect the LED against the sort of, well, to a degree, to limit the current more through the resistor, because on many LEDs, the red LEDs, when you exceed their reverse voltage, the red LEDs in particular, they will just conduct. And it means that the resistor will be doing double duty. But anyway, you've got the typical circuit in these is a resistor, a diode, and then the LED. And they repeat that. So there's 1, 2, and they repeat it 3 times. This is a green LED, this is a green LED, and this is the red LED. Now normally, when you plug it in, current should flow from live to earth and live to neutral. Neutral and earth should normally be the same potential. So normally the 2 green LEDs would light and the red one would not. If the red one does light, something has gone wrong. It means that it's most likely that neutral and live have been swapped. If this one doesn't light, it means earth's missing, and basically just various combinations. But the gist is that on most of these testers, the simple ones, that don't have extra circuitry, you get green for good and red for bad. And you don't really need the buzzer, although the buzzer that they have in this one is useful for just, knowing when you've switched something off at the distribution board if you're trying to trace a circuit. It also, in this case, if it detects the circuit's good, it will just beep continually if the 2 green LEDs are light. If the red one lights, or if there's a different combination, then it will pulse to show that there's a problem. It's a bit of a flippant thing, you can look at the LEDs and tell. However, what's different is this one, to power that circuitry here, because it is a little PIC microcontroller, it uses a bit of extra circuitry. So here's live, here's neutral, and here's earth. And to be able to power it in every combination, it has a diode bridge. And the diode bridge looks like this. You've got the positive rail, and you get the negative rail. You've got a diode from each of these going up to the positive rail. It's basically a bit like a bridge rectifier, but with 6 diodes. And you've got a diode going down to the negative rail. And that means that even if you just connect any 2 of these pins, you're going to generate a positive and negative rail. That is then limited by the 47K resistor, 47K, and then it goes through various, it's got a capacitor, it's got a zener, and it basically uses that to keep a nice stable 5-volt supply to power the microcontroller and the buzzer. And the other thing that it's got for the little microcontroller is it's got a resistor roughly, keeping it simple, it's got a resistor to every one of the poles just so it can detect their state if they're actually showing the signal or not. And, it can work out from that if it's a valid power state and whether it should beep continuously or pulse. It's a lot of circuitry for very little. I mean, look at this circuit board. 3 of the diodes, these 3 are for the LEDs. So the LEDs, the resistors there, and these 3 big resistors would do the work. Everything else, all the other diodes, the 6 other diodes, all these resistors, the buzzer and this resistor here are just purely for that peeping function. So let's move up a bit the focus and let's do some tests and see what happens. I should mention I took a look at that with the thermal imaging camera. The resistor in the middle is getting quite hot. It goes up to 160 degrees Celsius when it's been on for a while. That's the one that's doing quite a bit of duty because while the big resistors here are only operating on half the sine wave for the LED, the resistor in the middle is actually running on both halves of the sine wave to power the circuitry. It's an inefficient way of powering the circuit, but it was the simplest thing. That's what they did. So it gets pretty toasty hot. Let's nudge the focus up a bit. I'm going to use my horrible box of stuff here. I'm just going to zoom in that, make sure I have focused up. Yes, I have. Just double checking, And look, you guys have much, much bigger screens than I have. You'll see all these minor details. So here's the thing we're going to do. This is all dangling out. Yeah, sorry about that. It's not electrically safe, but let's just plug it in anyway. And once it makes connection, this hoppy tester is a horrible socket. The 2 green LEDs light and it works, but if there's a bad connection, let's jiggle it about till we get a bad connection. Now it's not going to do it. Yeah, anyway, it pulses. You'll hear that later because let's do the other test. Let's use the shitty adapter here, the death adapter, to defeat all safety. So I'm making the circuit live from the live pin by plugging it in upside down. And then I'm going to use the meter to test how much current actually flows to ground. So let's get this on. Let's put the meter into milliamps because it's not going to be that much current. Let's put it to AC milliamps. I kind of know what the circuitry is here, so I know what to expect. Let's put it 20 because it's not going to be that high, is it? So let's go between earth, make sure I get everything right before I do this to avoid huge bangs. So it's indicating a problem, and it's showing a current of about 3.5 milliamps on the meter, but it's notable that's on DC. Look at the hoppy meter and it's showing 10 milliamps. Now if I turn this to AC current, oh, that's quite weird. What the fuck is going on there? Oh, that's the 20 amp setting. You dick, Clive. You dick. This is not strange for me, is it really? Okay, here we go. That's better. So now it's happy now. And it's showing 9.1 milliamps. So let's do the maths here and see how much current is actually flowing. And we can do the maths by working it out from the resistors. So, depending on how many LEDs are lit, let's turn this on. Depending on how many LEDs are lit, we've got the 33k resistor, so 240 volts divided by 33k. The current flowing through the LEDs, it's 7 milliamps, but it's only on for half the time. But it is, it's averaging about 3.5 milliamps, but it is peak 7 milliamps. Then you add to that the fact that this is operating, the 47k resistor is operating on every half of the cycle. So 240 divided by the 47k equals, and that's about 5 milliamps. So that's adding up in the region of 8 milliamps, but peaking at a bit more. It's peaking at over 10. That is actually quite savage. That's a beast. That would hurt. I can see perhaps why they're doing this now. This tester, on the other hand, this one just plays it dumb. It's not really aiming for anything special. You plug it in, the LED's light. They're using white phosphor LEDs underneath green covers in this, which is quite neat. But the current from this one is going to be very different. It's going to be DC biased. So let's stick it to there and test, and it's just 1 milliamp. 1 milliamp, which you'd feel up one finger, but you wouldn't really feel. If you're holding something in the hand, you might get a slight tingle, but it wouldn't be really anything dramatically noticeable. That's why I kind of like these testers. Let's try this tester. Noting that if you tested this and it didn't seem to be working, then you just press this earth leakage test button anyway, that would pass over 30 milliamps through the earth. That would be pretty intense. Let's test this and see what we get. We're getting about 3.5 milliamps. Yeah, that is getting a bit bitier for such a simple design. But this is not a simple design, it's a complex design. It was a horrible design. That is definitely, as I say, this one is my preferred one of these. Now, just out of interest, what about, this is the one I use. So let's see what this one's going to be doing. Meter in. So I think it's going to be AC here because it's probably got that same resistor arrangement inside. So let's test that again. Yeah, this one's doing the same. It's putting about 9 milliamps. That is quite a lot of current. This one also, if it only does the thing, if it detects a good circuit, it will then go through another test. It will go through a test sequence and it will do a loop test as well. It's saying check here because this is a TT electrical system. It always has a high sort of loop impedance just because of the way the power is supplied. So, yeah, I don't know. I can see why Fluke are recalling them because that is a bit of an issue, particularly in this day and age of people being all sort of litigious for every detail. But I would say it's just collateral damage of using one of these testers. The downside is that if you plug it in an office type environment, you don't know if someone somewhere might coincidentally be downstream of an earth fault and they could get a tingle. And, the chance of them getting a tingle, they'd have to be holding something grounded at the same time as they holded something that was supposed to be earth, that actually was earth. So it's very remote, the chance of this happening. But it's there, and I'm guessing that's why Fluke are really just drawing them in and, bring them back. So I don't blame Fluke for that at all. It's just collateral damage of this type of tester. They always do have that leakage current. It's just maybe a bit more savage because the extra features they've added in. But it just shows that, if you want a tester for things like that, these ones are the absolute safest because they do pass the smallest amount of current. And if you're using something more sophisticated like this, then just be very aware when you're using them. And if you do decide to keep your Fluke one, just always be aware of your environment when you're using it and allow for the fact that, some fault conditions may result in other metalwork coming live. But there you go. Interesting scenario.